Hey everyone, so this is going to be part 2 of our Flappy Bird game, and in this part we're going to be creating a narrow passage, checking for a collision, and creating a scoreboard. So the first thing we could do is create a board class, or not a board class, a block class. And so this will just be the blocks that the bird needs to fly through. So class block, define init, self, x, y, width, and height. Self.x is equal to x, self.y is equal to y, self.width is equal to width, self.height is equal to height, and self.gap is going to be equal to 120. And so here the x, y is the coordinate, and the width and the height are the sizes of the top block. And now let's create another function, define draw, and this will just draw our block. And the parameters can be self and window. And so we want to pygame.draw.rect, draw the rectangle, window, brown, the color brown, self.x, self.x, 0, because we want it to start, this is 0 because we want it to start at the top, right? Or at the top, self.width, self.height. And this will draw top block. And now what we could do, bottom block y, this is just going to be equal to the self.height plus self.gap, and this will be for the top of the bottom block. And now we can create another variable, bottom block height is equal to bottom b minus bottom block y. And this is the height of the bottom block. And now we can just pygame.draw.rect the bottom block. So we could draw the bottom block now. So window, the color brown, self.x, bottom block y, self.width, and bottom block height. So now in our gameMove function, let's create an object of this block class. So we want to create a few variables. So block height or block width is going to be equal to random.randint. We're making use of the random module we imported at the top, and the reason we're using random.randint is because we want to basically change the dimensions of this block so that it's not the same every single time, or else that'll be a boring game. Now block height is equal to random.randint 40 to 80. Block x is equal to int window width divided by 2, and block y is going to be equal to 0. So now we can create our object. Block is equal to block, and block x, block y, block width, and block height. Great. So now in our while loop, what we could do is actually draw our block. So of our block object, we can call the draw function with the window as a parameter. So if I run this, you'll notice that we have a block right here, and actually not a block, we have 2 blocks and we have a gap in the middle. So let me close this and let me run this again. Oh, yeah. Great. So now what we could do is we want the block to be able to basically move. So let's actually create another function for that. So here, let's first create a variable, self.speedx, and this is going to be the speed at which the block moves. And the speed is going to be -2. And let's create a update function of self, and this function will basically just move the block. So self.x is equal to the previous self.x value plus self.speedx. Let's save this. And inside of our game loop function, right here, we can call block.update. So let's save this and run. And now you notice that the blocks move to the left. Great. So what we could do now is we want to basically have boundary checking. And we want the block to reappear after disappearing from the left. So you notice that when the block moves to the right, the block does not reappear. And that's what we want to check right now. So in the update function we created before, right here, we can check if self.x plus self.width is less than 0. So if the right part of the block is to the left of the left side of the window, then we want to set the location of the block to the right side of the window. So it looks like it's just reappearing. So self.x is equal to window width. Self.width is equal to random.randint 30 150. Self.height is equal to random.randint 40 and 280. And here we're just changing the width and the height again. So if I run this, the blocks move to the left, and we have the blocks reappear. Great. Now it has the illusion that there's going to be an infinite amount of blocks. Cool. So now let's go back into our game loop, and there's an edit I want to make. Instead of setting block x is equal to int window width over 2, notice how if I leave it as it is, the block spawns near the center, and I just want the block to spawn at the end. So I'm just going to set block x is equal to window width. So now if I run this, now the block spawned on the right side. Great. So let's create collisions. So collision between the bird and the block. So let's create a function above. Yeah, we can create it above the game loop. So we can call this define crash. And when the player crashes into the block, we basically just want to show text saying you crashed. So font is going to be equal to pygame.font.font, and the font none, size is 70. Text is equal to font.render. Oh, you crashed. And that's just going to say you crashed in the center. True. And the color is going to be black. Now the text width is going to be equal to text.getWidth. Text height is equal to text.getHeight. X is going to be equal to int window width over 2 minus text width over 2. And y is equal to 150. And now we can blit this onto the screen. So window.blit the text at the position xy. And now we want to pygame.display.update to update pygame. And then we want to call the time.sleep. And what this will do, time.sleep is going to stall our program for the 2 seconds. And this will be enough time for basically the block or the player to read the you crashed message. And then after this, we will recall the game loop. So let me save this and run. Oh wait, we didn't even actually call it. Okay. So that's not all there is to it. Let's actually go into, let me actually pull up a slideshow so we can see the theory or idea behind collision. So here we have a block, which is this yellow box. And basically, how do we detect collision on the x-coordinate? Well, how we do this is we check if the player.x plus player.width, so that's basically the right side of the player. If this right side of the player is greater than the left side of this block, then that means that, well, this right side is somewhere over here on the right side of this block. And we want to check if the left side of the player, so this left side, is less than the right side of this block. So if both these conditions are true, that means that the block is somewhere that is colliding with this player, or the player is colliding with the block. But this is only for the x coordinate. So now let's go into the y coordinate and check. So here we have player, if player.y is less than block.height, and player.y is the top of the block, if that's less than block.height, which is this part, or if, so if player.y, the top part, is less than block.height, that means player is colliding with this part somewhere inside of this block. Or if player.y plus player.height, which is the bottom part of the block, if that is greater than the bottom block height, which is here, then that means that this part of our player is below or inside of this block. And so if we combine both of these ideas, the x coordinate and the y coordinate, and check for both of these conditions, and if both of them are true, then that's how we know that, well, the player has collided with the block on the x and the y coordinate. So let's actually implement this into our code. So let's go back. And inside of our game loop function, let's go over here. Right, player.draw, block.draw, we can call it right here. We want to check for collision with, or collision with block. And we want to create a variable, so bottom block height, and that's equal to the block height, block.height, plus block.gap. And now, again, back into the slideshow, we want to check for both of these conditions. And this if statement right here, if player.x plus player.width is greater than block.x and player.x is less than block.x plus block.width. So this would be checking for the x coordinate. Now if player.y is less than block.height, or player.y plus player.height is greater than bottom block height, then we want to call the crash function from before. So if I save this and run our code, well, you notice I've crashed and I basically respawn. Great. So now I've crashed at the top and bottom part. You noticed. Let me actually try to play and beat the game here. 1, 2. Oh, I crashed. Well, before we finish, let's actually add a scoreboard. And right above our game function, or actually our crash function, let's create another function, define scoreboard. And we're going to have a parameter passed. And font is equal to pygame.font.font, none, size 20. Text is equal to font.render, and this is going to render passed, and this is just going to show how many are passed. Oops, where did that go? Oh, passed plus string passed, and yeah, that's just going to have a int variable showing how many we've passed. True. And now window.blit text 0, 10, and that's going to be the x and y coordinate of the text itself. So now let's go into our block class over here, and let's create another value. So find block self.pass, and this is just going to show how many blocks that the block, how many blocks that the player passed. Yeah. So in this update function here, when the block goes off screen to the left, that means that the player has passed the block. And when that happens, we want to increase the passed value. So self.passed is equal to the previous self.passed value plus 1. And now in our game loop, let's go back into our game loop, we can call the scoreboard. So scoreboard with block.passed. So we could save this and run. And here you notice that we have a passed checker on the top left. And when I passed 1 block, I passed 2 blocks. Let me just try to keep going for as long as I can. 3. Well, it looks like I crashed at 4. So there. Now we have a working Flappy Bird game. And that'll be the end of this tutorial, and I'll see you guys in the next one.